Now the vapor under the high pressure enters into the condenser C. Now the vapor under high pressure enters into the condenser C. As the condenser is surrounded by enclosure, in which cold water is circulated, Okay, ma. The heat of compression is removed. So the vapor under high pressure. And low temperature liquefies in condenser. The liquid represent passes through the regulated valve. V into evaporation E. The valve V reduces pressure. Of liquid represent. Due to low pressure. Liquid evaporates in evaporation and producing cooling effect according to the principle. That is, evaporation of liquid under reduced pressure is a cooling process. Important. Evaporation of liquid under reduced pressure. Evaporation of liquid under reduced pressure is a cooling process. When the liquid evaporates in evaporator, it extracts latent heat of vaporization. When the liquid evaporates in evaporator, it extracts latent heat of vaporization from surrounding cold storage space. As more liquid evaporates in evaporator, more cooling is produced. And the temperature of storage spaces lowered. After a certain time, the temperature reaches the desired value. Therefore, the above cycle is repeated. Again and again. Now, we are taking a distinction between Joule expansion, Joule-Thomson expansion, and adiabatic expansion. Important. That is short answer. What is the differences between expansion and Joule-Thomson cooling and adiabatic expansion? For that, we are giving data. Here, what are the differences between Joule expansion, Joule-Thomson expansion, and adiabatic expansion? That we will complete today class. Next class we will discuss quantum theory of radiation. Important. Wien's displacement law, emissive power, absorptive power, convection, radiation, and spectral emissive power, black body, Ferri's black body, distribution of energy of the spectrum of black body, Wien's displacement law, Planck's law, Rayleigh's law, that we discuss in next class. Next statistics. Now I will complete this Joule expansion. What is Joule expansion? It is a free expansion. That is Fermi-Dirac statistics is last unit. Before going to that, quantum theory of radiation lesson is there that we are completed, means maximum percentage of syllabus is completed in this lesson. Okay, tomorrow is last class. Now that's what we completed. That Planck's law, Rayleigh's law, Wien's displacement law. Now we'll go for Joule-Thomson cooling. What is Joule-Thomson cooling? Joule expansion, it is free expansion in which the gas expands into vacuum. It is a free expansion in which the gas expands into vacuum. Hence, does no external work. In this expansion, internal work is done by the gas against intermolecular attraction forces. So the contribution of net external work done. May be a cooling effect or heating effect. Therefore, the contribution of net external work may be a cooling effect or a heating effect depending upon the initial temperature of the gas. Okay. Next, Joule-Thomson or Joule-Kelvin expansion. Joule-Thomson or Joule-Kelvin expansion. In this, what it is? When a gas under high pressure, when a gas under high pressure is forced to pass through a porous plug, when a gas under high pressure is forced to pass through the porous plug to a region of low pressure, to a region of low pressure, hence the external work is done. Hence, the external work is done on the gas. Hence, the external work is done on the gas as well as by the gas in addition, as well as by the gas in addition to, as well as by the gas in addition to internal work. There may be a cooling effect, there may be a cooling effect or heating effect. There may be a cooling effect or a heating effect. Depends on initial temperature of the gas. Next, adiabatic expansion. In this type of expansion, the compressed gas is suddenly released. In this type of expansion, the compressed gas is suddenly released to atmosphere. Hence, the gas performs external work against the pressure of the atmosphere. Against the pressure of the atmosphere, ma'am. In this expansion, the compressed gas is suddenly released to atmosphere. Hence, the gas performs external work against the pressure of the atmosphere. This process is very fast that no considerable heat flows into gas. That no considerable heat flows into the gas from surroundings. Hence, the external work is drawn from the internal energy. Hence, the external work is drawn from the internal energy of the gas. As a result, the gas showing cooling effect. As a result, the gas showing cooling effect. Now, what is Joule-Thomson cooling? What is adiabatic demagnetization? We have the important formula. What it is, ma? dt is equal to P1 minus P2 by Cpj into 2A by RT minus B. And again, adiabatic demagnetization is Tf minus Ti is equal to minus Kbi square by 2Cbt, which is the important equations in this particular lesson. Okay, ma? Is there any doubt? Okay. Tomorrow class we will discuss quantum theory of radiation and different laws. Quantum theory of radiation, basically heat or radiation can be transformed into three ways: conduction, convection, and radiation. What is conduction, convection, and radiation? And thermal radiation. Conduction means the transmission of heat takes place from one point to other without motion of particles is called as or is known as conduction. In this mode of heat transmission, particles or molecules transfer heat by collisions. Next, convection. The transmission of heat takes place from one place to other place with the motion of particles. With the motion of particles or molecules is known as convection. And radiation means the process of heat transfer from a body by virtue of its temperature, For this, the process of heat transfer from a body by virtue of its temperature without the involvement of the interviewing medium is known as radiation. Okay, ma? Like that, we have the three types of modes of vibration is there. Radiation is there, ma? Then thermal radiation. The radiation emitted by a body by virtue of its temperature is called thermal radiation. That we will discuss in next class. Okay, Nana? We'll continue tomorrow class.